Good morning. Today I am going to discuss few NEET, CET and JEE questions on the topic oscillations and waves. First question, the two nearest harmonics of a tube closed at one end and open at other end are 220 Hz and 260 Hz. What is the fundamental frequency of the system? So, in this question, two frequencies are given. They are the two nearest harmonics. In case of closed pipe, harmonics differ by 2. So, if one frequency is n into f, another should be n plus 2 into f. N into f is given as 220 Hz. N plus 2f is equal to 260 Hz. You have to find out the fundamental frequency equal to f. So, subtract equation number 1 from equation number 2, which gives rise to 2f equal to 260 minus 220 equal to 40 implies f equal to 40 by 2 equal to 20 Hz. So, the fundamental frequency is 20 Hz, hence answer is choice B. Second question, a siren emitting a sound of frequency 800 Hz moves away from an observer towards a cliff at a speed of 15 meter per second. Then the frequency of sound that the observer hears as the echo reflected from the cliff is. Velocity of sound in air is given, which is equal to 330 meter per second. So, in this question, observer O is at rest. So, V naught equal to 0. There is a source producing sound which is moving with the speed Vs equal to 15 meter per second towards a cliff. There is a cliff here. So, observer should hear the sound reflected from the cliff. Therefore, sound should move towards the cliff. Its speed is given, which is equal to 330 meter per second. To calculate frequency of sound heard by the observer, we have to use the formula f dash equal to true frequency f into V minus V naught divided by V minus Vs. True frequency f is given, which is equal to 800 Hz. Speed of sound V is given, which is 330, V naught equal to 0, V 330, Vs is in the direction of V, so take it positive, therefore it should be plus 50, which gives rise to 838 Hz. So, the correct answer is choice B. The number of possible natural oscillations of air column in a pipe closed at one end of length 85 centimeter whose frequencies lie below 1250 Hz are. Velocity of sound is given 340 meter per second. So, you have to calculate how many frequencies are possible. It is a closed pipe. In closed pipe, frequency ratio is nothing but 1:3:5, so on. So, to find out the number of frequencies, you have to calculate fundamental frequency, which is equal to V divided by 4L. V is given 340, 4 into length of the pipe is given, which is 85 into 10 to the power minus 2, which gives rise to 100 Hz. So, total number of frequencies are 1 into 100, 100, 3 into 100, 300, 500, 700, 900, 1100. Next comes 13, which exceeds the value 1250 hertz. So, number of frequencies are total 6. Therefore, the answer should be D. Fourth one, a source of unknown frequency gives 4 beats per second when sounded with a source of known frequency 250 hertz. The second harmonic of the source of unknown frequency gives 5 beats per second when sounded with a source of frequency 513 hertz. The unknown frequency is. In the first case in this question, 250 hertz gives a beat of 4 with the unknown frequency. Therefore, frequency of unknown should be equal to 250 plus 4, which is 254 hertz, or 250 minus 4, which is equal to 246 hertz, since beat frequency is the difference of two frequencies. The second harmonic of the source of unknown frequency gives 5 beats when it is sounded with a tuning fork of frequency 513. So, in the second case, F unknown should be 513 plus 5, which is 518 hertz, or 513 minus 5, which is equal to 508 hertz. This is the first harmonic, this is the next harmonic. So, in case of vibrations, frequencies may differ by 1:2 or 1:3. In first case, all harmonics are present. In second case, only odd harmonics are present. So, either second should be double of the first, or second should be thrice the first. Here thrice is not there, so should be double. 254 into 2 is nothing but 508 hertz, which is there. Therefore, the first harmonic frequency should be 254. So, frequency should be 254 hertz. So, the answer should be E. Fifth one, two identical piano wires kept under the same tension T have a fundamental frequency of 600 hertz. The fractional increase in the tension of one of the wires, which will lead to occurrence of 6 beats per second when both wires oscillate together, would be. So, initially both piano wires have same frequency, which is 600 hertz, kept under identical tension. Now, you have to calculate what is the increase in the tension when frequency difference of the two equal to 6. So, in case of piano, nothing but a stretched string, frequency is directly proportional to square root of tension. Therefore, fractional change in the frequency should be equal to half of fractional change in the tension. Therefore, delta T by T is nothing but 2 times delta F by F. Delta F is given, difference in the frequency, which is 6. Frequency F is given, which is 600, which gives rise to 2 by 100, which is equal to 0.02. So, the answer should be A, 0.02. A transverse wave is represented by the equation y equal to A sin omega t minus k into x. For what value of the wavelength is wave velocity equal to the maximum particle velocity. Wave velocity is given by the formula omega by k. It is given to be equal to maximum particle velocity, which is nothing but omega into A. This gives rise to 1 by k equal to A, but k is equal to 2 pi divided by lambda, which is equal to E. So, you have to find out for what value of wavelength lambda. So, what is the value of lambda? Lambda equal to 2 pi into A. So, the answer should be the equation of displacement of two waves are given as y1 equal to 10 sin 3 pi t plus pi by 3 and y2 equal to 5 sin 3 pi t plus root 3 cos 3 pi t. Then what is the ratio of their amplitudes? So, displacement of two waves are given, you have to calculate ratio of their amplitudes. To compare the amplitudes, both should be in the same form. So, I will convert first equation into second form, 10 sin. Expand the equation by using sin A plus B form, which gives rise to sin 3 pi t cos pi by 3. Cos pi by 3 is nothing but 1 by 2 plus cos 3 pi t into sin pi by 3, which is nothing but root 3 by 2. I will take 1 by 2 outside, 10 by 2 is nothing but 5 sin 3 pi t plus root 3 cos 3 pi t. Now, compare these two equations, both have same amplitude, therefore, the ratio of amplitude A1 by A2 is 5 by 5, nothing but 1. So, the answer should be 1:1, C is the. Two waves having the intensities in the ratio of 9:1 produce interference. The ratio of maximum to the minimum intensity equal to ratio of frequencies intensity is given I1 by I2 equal to 9 divided by 1. You have to find out ratio of maximum intensity I maximum by I minimum. In terms of intensity, this can be written as 1 plus root of I2 by I1 square divided by 1 minus root of I2 divided by I1 square. So, 1 plus I2 by I1 is nothing but 1 by 9 square of that, 1 minus root of 1 by 9 square. This gives rise to root of 1 by 9 is 1 by 3, 1 plus 1 by 3 is nothing but 4 by 3 square of that, 1 minus 1 by 3 is nothing but 2 by 3 whole square, which is 4 by 2 square, which is equal to 4 by 1. So, the answer should be P. A body of mass m is attached to the lower end of a spring whose upper end is fixed. The spring has negligible mass. When the mass m is slightly pulled down and released, it oscillates with a time period of 3 seconds. When the mass m is increased by 1 kilogram, the time period of oscillation becomes 5 seconds. What is the value of m in kilogram? There is a spring, one end is fixed, to another end mass m is attached. M is slightly pulled down and released. It executes simple harmonic motion where t is the period which is given. As the mass changes, period also changes here. That two are related by t proportional to root of m. Therefore, T1 divided by T2 is root of M1 divided by M2. Initial time period is 3, second time it is 5. Initial mass is M, then it is increased by 1 kg m plus 1. To eliminate square root, squaring the both sides, 9 by 25 equal to m divided by m plus 1, which gives rise to 9m plus 9 equal to 25m. 25 minus 9 is nothing but 16. So, 9m equal to 16, m equal to 16 divided by 9. So, the answer should be B. Ratio of kinetic energy to the potential energy of a particle executing simple harmonic motion at a distance equal to half of its amplitude. The distance being measured from its equilibrium position is. Ratio of kinetic energy to the potential energy of a particle executing SHM at a distance equal to half of its amplitude. The distance being measured from its equilibrium position is. Ratio of kinetic energy to the potential energy is given by the formula A square minus y square divided by y square. This ratio when y equal to a by 2 is required. So, this is equal to a square minus displacement is a by 2 whole square by a by 2 whole square, which gives rise to a square minus a square by 4 by a square by 4, which is equal to 3a square by 4 divided by a square by 4, which is equal to 3 by 1. So, the answer is A. The period of oscillation of a simple pendulum is t equal to 2 pi root of L by G. The measured value of L is 20 centimeter known to 1 millimeter accuracy, and the time for 100 oscillations of the pendulum is found to be 90 seconds using a wrist watch of 1 second resolution. The accuracy in the determination of gravity G is. In this question, time period is equal to 2 pi root of L divided by G. When there is error in the measurement of L and T, there is error in the measurement of G. You have to calculate accuracy in the determination of G. Squaring both sides, T square is 4 pi square into L by G. From this formula, delta G by G is equal to delta L by L plus 2 times delta T by T, delta L by L plus 2 times time period is not given but is proportional to time. So, delta T divided by T. Measured length is given, accuracy of measurement is given. So, measured length is 20 centimeter, accuracy is 1 millimeter means 0.1 centimeter, 2 times time measured is 90 second, accuracy nothing but 1, which gives rise to nearly 0.03. Therefore, delta G by G in percentage is 3. So, the answer should be B. The amplitude of a damped oscillator becomes half in 1 minute. The amplitude after 3 minutes will be 1 by x times the original, where x is. Amplitude of damped oscillator is given, which is given by A naught e to the power minus b into t. In the first case, amplitude is A naught by 2. Corresponding time is nothing but 1 minute. In the second case, amplitude has to be calculated. Time interval is nothing but 3 minutes. If I simplify this, A naught by e power 3b can be written as e power b whole cube. Get the value of e power b from the first formula. A naught goes 1 by 2 equal to 1 by e power b. So, e power b is nothing but 2. Therefore, this is a naught by 2 cube, which is given as 1 by x. So, x equal to 2 cube. So, the answer should be B. The second overtone of an open organ pipe has the same frequency as the first overtone of a closed pipe L meter long. The length of the open pipe will be. So, two pipes are given, open and closed pipe. They are vibrating with the same frequency, but vibrating in the different mode. For open pipe, it is the second overtone whose frequency is 3V by 2 times L. Its frequency is equal to the closed pipe vibrating in the first overtone, which is 3V by 4 times the length. You have to find out length of the open pipe. 3V cancels to 2L0 equal to 4LC, or L0 equal to 2LC. LC is given as L. So, length should be 2L. So, the answer is B. A uniform rope of length L and mass M1 hangs vertically from a rigid support. A block of mass M2 is attached to the free end of the rope. A transverse pulse of wavelength lambda 1 is produced at the lower end of the rope. The wavelength of the pulse when it reaches the top of the rope is lambda 2. Find the ratio of lambda 2 to lambda 1. A uniform rope of length L and mass M hangs vertically from a rigid support. There is a rigid support. Here is the rope of mass M1. A block of mass M2 is attached to the free end of the rope. A wave pulse is generated here. Here a wave pulse of wavelength lambda 1 is produced, which propagate to the fixed end of the string. You have to find out ratio of lambda 2 to lambda 1. In case of rope, velocity is proportional to root of tension, but velocity is proportional to wavelength. Therefore, wavelength is proportional to root of tension, but tension is proportional to weight. Weight is proportional to mass. Therefore, lambda 2 divided by lambda 1 is root of M2 divided by M1. Lambda 1 is the wavelength when it is at the bottom where only mass M2 acts. Therefore, M2 is the mass when it reaches the top. There M1 as well as M2 acts. Therefore, it should be M1 plus M2. So, the answer should be root of M1 plus M2 by M2. So, E is the answer. A speeding motorcyclist sees a traffic jam ahead of him. He slows down to 36 km per hour. He finds that traffic has eased and a car moving ahead of him at 18 km per hour is honking at a frequency of 1392 Hz. If the speed of sound is 343 meter per second, the frequency of the honk as heard by him will be. In this question, a speeding motorcyclist sees traffic jam ahead of him. He slows down to 36 km per hour and ahead of him a car is moving which produces the sound. So, first car is the observer, second is nothing but the source. So, observer is moving with a velocity of 36 kilometer per hour, which is 36 into 5 by 18, which is 10 meter per second. Ahead of the observer there is another car, which is the source, moving with a velocity Vs equal to 18 kilometer per hour, which is 18 into 5 by 18, 5 meter per second. Now the second car produces the sound that should be heard by the first observer. So sound should move towards the observer. Frequency of the sound heard by the observer is given by F into V minus V naught by V minus Vs, where F is the true frequency, which is 1392. Velocity of sound is given 343. Observer is moving opposite to the sound, should be taken negative minus 10. 343 minus source is also moving opposite to sound, should be taken negative minus 5, which is equal to 1412 hertz. So the answer is C. A wave traveling in the positive x direction having displacement along y direction as 1 meter, wavelength 2 pi meter, and frequency of 1 by pi hertz is represented by. A wave traveling in the positive x direction is required. Displacement is given, which is equal to 1 meter. Wave traveling in the x direction is given by the formula y equal to a sin omega t minus kx, or kx minus omega t, or kx minus omega t form is there. So y equal to a sin kx minus omega t. Amplitude is given, which is equal to 1 meter. Wavelength is given 2 pi meter. Frequency is given. I will modify the formula. A sin k can be written as 2 pi by lambda x. Omega can be written as 2 pi f into t. Displacement amplitude is 1 sin 2 pi by wavelength is 2 pi meter. 2 pi into frequency is 1 divided by pi, which gives rise to sin x minus 2t. So the answer should be E. Two periodic waves of intensities I1 and I2 pass through a region at the same time in the same direction. The sum of the maximum and minimum intensities is. So intensity of two waves is given, I1 and I2. You have to find out sum of the maximum and minimum intensities. I maximum plus I minimum is required. Maximum is produced when they superpose in phase. Phase difference should be equal to 0 degree. At that time we can write as root I1 plus root I2 whole square plus. To produce minimum intensity, they should superpose out of phase. Phase difference is 180. So root I1 minus root I2 whole square. If you simplify this, gives rise to 2 into I1 plus I2. So the answer should be D. 2 points are located at a distance of 10 meter and 15 meter from the source of oscillation. The period of oscillation is 0.05 second and the velocity of the wave is 300 meter per second. What is the phase difference between the oscillations of 2 points? So from the origin O, 1 point is at a distance of 10 meter. Another point is at a distance of 15 meter. So between these 2 points, distance equal to 5 meter, which is the path difference. So, path difference between the 2 points equal to 5 meter. Calculate phase difference. How phase difference is related to path difference? Phase difference is 2 pi by lambda into phase difference. Phase difference is given by delta phi equal to 2 pi by lambda into path difference. 2 pi by lambda is not given, but v equal to f into lambda. Lambda equal to v by f or v into t. So, v into time period t into delta x, which is 2 pi by velocity is 300, time period is 0.05, path difference is nothing but a 5. 300 into 0.05 equal to 15, 5 by 15, 1 by 3. So, the answer is 2 pi divided by 3. So, B is the answer. Intensity level of a sound whose intensity is 10 to the power minus 8 watt per meter square is. Here intensity of sound is given, you have to calculate intensity level. Intensity level or loudness equal to 10 log I divided by I naught, where I naught is called threshold of hearing. I is the intensity of the given sound, which is 10 log. Intensity of the given sound is 10 to the power minus 8. Threshold of hearing is standard value, which is 10 to the power minus 12, which is equal to 10 log 10 to the power 4, which is 40 log 10, which is equal to 40. Unit is nothing but decibel. So, the answer is C. A source producing sound of frequency 170 Hz is approaching a stationary observer with a velocity 17 meter per second. The apparent change in the wavelength of sound heard by the observer is. Speed of sound in air is given 340 meter per second. So, source is producing the sound of frequency 170 Hz. You have to find out change in the wavelength. Hence, calculate initial wavelength lambda. V equal to f lambda. Therefore, lambda is V by f. Velocity equal to 340. Frequency 170. So, initial wavelength equal to 2 meter. Whenever source is approaching the stationary observer, so there is observer who is at rest. Source is approaching the observer, speed is 17 meter per second. Sound should move towards the observer. Then apparent wavelength is given by lambda dash. V equal to f lambda, lambda V by f dash, which is V divided by f dash is f into V minus V naught divided by V minus Vs, which is equal to V 340 into 340 minus Vs in the direction of V should be taken positive 17, f equal to 170, V equal to 340, observer is a stationary, this comes equal to 1.9 meter. Therefore, delta lambda is initial wavelength 2, now it is 1.9, 2 minus 1.9 is 0.1 meter. So, the answer is A. 10 tuning forks are arranged in increasing order of frequency in such a way that any two nearest tuning forks produces 4 beats per second. The highest frequency is twice of the lowest, possible highest and the lowest frequencies are. In this question, if n number of tuning forks are increased in the or are arranged in the increasing order of frequency, then frequency of the last fork is always equal to frequency of the first plus number of tuning forks minus 1 into frequency difference of the two, also called beat frequency between the two. Frequency of the last is given, which is twice the first one. Number of tuning forks given, which is equal to 10. Frequency difference of successive forks is given, which is equal to 4. 10 minus 1, 9 into 4 equal to 36, 2f1 minus f1, f1 equal to 36. So, frequency of the first fork is 36. So, last fork is double the first, 2 into 36, which is equal to 72. So, frequency of the last highest is 76, lowest is 36. So, the answer is D. A transverse wave is described by the equation y equal to y naught sin 2 pi ft minus x by lambda. The maximum particle velocity is 4 times the wave velocity if maximum particle velocity is omega a should be 4 times the wave velocity. Wave velocity is given by omega divided by k. You have to calculate value of the wavelength. Omega cancels, so a into k equal to 4. Value of k is required. If I modify this, y naught sin 2 pi ft minus 2 pi by lambda into x is of the form a sin omega t minus kx. So, amplitude equal to y naught, k equal to 2 pi by lambda equal to 4, implies lambda is 2 pi y naught divided by 4, which is equal to pi y naught divided by 2. So, the answer is B. Average velocity of a particle executing simple harmonic motion in one complete vibration is. How to calculate average velocity when one vibration is completed? Whenever one vibration is completed, displacement equal to 0, hence average velocity should be equal to 0. So, the answer is B. A mass m is suspended by two springs of force constants K1 and K2 respectively as shown in the diagram. The total elongation of the two springs is. Two springs are given having spring constants K1 and K2 here. They are connected in series. You have to find out total elongation of the spring. One spring has spring constant K1, another has spring constant K2 to which mass m is attached. Weight acting on the spring system is m into g should be equal to restoring force, which is nothing but K effective into elongation x. M into g, K effective is the effective spring constant. Since springs are connected in series, it is K1 K2 divided by K1 plus K2 into x, implies x equal to m into g into K1 plus K2 divided by K1 K2. So, the answer should be B. In damped oscillations, amplitude of oscillation is reduced to 1/3 of its initial value A naught at the end of 100 oscillations. When the oscillator completes 200 oscillations, its amplitude must be. From 100 and 200 oscillations, you can find out 2 time intervals. So, find the amplitude whenever it completes 200 oscillations. Amplitude A is given by the formula A naught e to the power minus B into T. In the first case, amplitude is 1/3 A naught. Time taken is 100 times the time period. So, 100 T into B. In the second case, amplitude is required, which is A naught e to the power minus total oscillations 200. So, time should be equal to 200 times the time period. This can be written as A naught by e to the power 100 BT whole square. Get the value of this from the first formula. 1 by 3 equal to A naught goes 1 by e to the power 100 BT. So, e to the power 100 BT is nothing but 3. So, this is equal to A naught by 3 square, which is A naught divided by 9. So, the answer is D. A simple pendulum has time period T1. The point of suspension is now moved upward according to the equation y equal to k into t square, where k equal to 1 meter per second square. If new time period is T2, then ratio T1 square by T2 square will be. So, initially simple pendulum is in the inertial frame of reference. Now, as it is moved upwards, it gets accelerated, hence effective gravity changes. As G changes, time period changes. How they are related? Time period is inversely proportional to root of gravity. Therefore, T1 square by T2 square equal to G2 by G1. Initially no acceleration G, then it moves upward, therefore G plus E. To get the value of E, use the equation y equal to kt square, implies E is d square y by dt square, which is 2 into k. Value of k is given as 1, which is 2 meter per second square. Therefore, T1 square by T2 square is G 10 plus 2 by 10, which is 12 by 10 equal to 6 divided by 5. So, the answer is C. A body executing simple harmonic motion has a maximum acceleration equal to 24 meter per second square and maximum velocity equal to 16 meter per second. The amplitude of the simple harmonic motion is. Maximum acceleration, A maximum is given 24 meter per second square. V maximum is given, which is equal to 16 meter per second. You have to calculate amplitude of the simple harmonic motion. This is nothing but omega square into E. This is nothing but omega into E. Therefore, A equal to V maximum divided by omega, which is equal to V maximum by omega can be written equal to A maximum divided by V maximum, which is V maximum 16, A maximum 24, V maximum 16, which is 16 into 16 divided by 24. 8 into 2, 8 into 3. So, the answer should be 32 divided by 3. So, answer is E. An air column closed at one end and open at the other resonates with a tuning fork when the smallest length of the column is 50 centimeter. The next larger length of the column resonating with the same tuning fork is. Given pipe is a closed pipe which has smallest length 50 centimeter. Now it is vibrating in the fundamental frequency. Calculate the next larger length when it resonates with the same tuning fork. You have to find out frequency of a second mode in the closed pipe. In closed pipe, frequency ratio is 1:3:5. Length ratio is also equal to 1:3:5. Therefore, L2 should be 3 times L1, 3 into 50, which is 150 centimeter. So, the answer should be B. Two waves are represented by the equation y1 equal to A sin omega t plus kx plus 0.57 meter and y2 equal to A cos omega t plus kx meter, where x is in meter and time is in second. The phase difference between them is. So, two equations are given. You have to find out the phase difference of the two waves. To find the phase difference, they should be in the same form. So, I will convert second equation into the form of first, which is A sin omega t plus kx plus pi by 2 meter. Now, phase difference is nothing but difference in the phases of these two, which is pi by 2 minus 0.57. Pi by 2 is 3.14 by 2, which is 1.57 minus 0.57, which comes as 1 radian. So, the answer is D. Each of the two strings of length 51.6 centimeter and 49.1 centimeter are tensioned separately by 20 Newton force. Mass per unit length of both the strings is same and equal to 1 gram per meter. When both the strings vibrate simultaneously, the number of beats is. Here two strings are given, their length given, both are tensioned to the same force, so 20 Newton. You have to find out number of beats produced per second. So, beat frequency is nothing but F1 difference F2. For that you have to calculate frequency of both the strings. F1 is 1 divided by 2L into root of T by M. Length is L1. 1 by 2 into length of the first string is 51.6 into 10 to the power minus 2. Tension is 20 Newton. Mass per unit length is 1 into 10 to the power minus 3 kilogram per meter. This comes equal to 137 hertz. Frequency of the second string F2 is 1 by 2L2 root of T by M. 1 by 2 into length is 49.1 into 10 to the power minus 2. Tension 20, mass per unit length 1 into 10 to the power minus 3, which comes equal to 144 hertz. So, beat frequency is 144 minus 137, which is equal to 7 hertz. So, the answer is B. The sound intensity level at a 0.4 meter away from a point source is 10 decibel. Then the sound level at a distance 2 meter from the same source would be. So, 2 points are given, distance of them from the point to source is given. You have to calculate sound level at the second distance, sound level at the first distance is given. That is, difference in the sound level can be written as 10 log I1 by I2. L1 is the sound level when intensity is I1, L2 is the sound level when intensity equal to I2. But in case of point source, intensity is inversely proportional to square of the distance. Therefore, L1 minus L2 is 10 log R2 square divided by R1 square, which is 10 log R1 equal to 4 meter, R2 equal to 2 meter, which is 1 by 2 square is 1 by 4, 10 log 1 by 4, which is 10 into log 1 minus log 4, 10 into 0 minus 2 into 0.3010, which comes as minus 6, equal to L1, which is equal to 10 minus L2. Therefore, L2 equal to 16 decibel. So, the answer is A. The phase difference between 2 points is separated by 1 meter. In a wave of a frequency 120 Hertz is 90 degree. The wave velocity is. You have to calculate value of wave velocity. Separation between the 2 points mean path difference is given 1 meter. Corresponding phase difference is also given, frequency is given. So, wave velocity is nothing but f into lambda. F is known, find the value of lambda. Phase difference is given by 2 pi by lambda into path difference. Therefore, lambda is 2 pi into delta x by delta phi, which is equal to 2 pi into path difference is 1 meter, phase difference is 90 degree, equal to pi by 2, which gives 4 meter. Therefore, wave velocity equal to f 120 into lambda 4, which is equal to 480. So, the answer is C. If you set up the 7th harmonic on a string fixed at both ends, how many nodes and antinodes are set up in it? So, string should be vibrated in the 7th mode, implies 7th harmonic. Calculate how many nodes and antinodes are present. If string is vibrated in the 1st harmonic, it consists of one loop. So, one antinode, 2 nodes are produced. So, one harmonic gives one antinode, 2 nodes. Increase in the mode increases both antinode and node by 1. Therefore, 7th harmonic implies first harmonic 1 antinode, 7th made 7 antinodes. First harmonic 2 nodes implies 7 plus 1, which is equal to 8 nodes are present. Therefore, number of nodes is 8, number of antinodes is 7. So, the answer is E. A particle executes linear simple harmonic motion with an amplitude of 3 centimeter. When the particle is at 2 centimeter from the mean position, the magnitude of its velocity is equal to that of its acceleration. Then its time period in seconds is. Magnitude of velocity is equal to that of acceleration is given. V is equal to A. You have to calculate time period, amplitude is given, displacement from the mean position is given. V is given by omega into root of A square minus Y square. A is given by omega square multiplied by Y. Implies omega equal to root of A square minus Y square by Y. But omega is 2 pi by T, which is root of A square minus Y square by Y. You have to calculate time period, which is 2 pi into Y by root of A square minus Y square. 2 pi into displacement is 2 centimeter, amplitude is 3 centimeter, displacement 2, which gives rise to 4 pi divided by root 5. So, the answer should be 4 pi by root pi. C is the answer. Infinite springs with force constant K, 2K, 4K and 8K so on respectively are connected in series. The effective force constant of the spring will be. So, infinite number of springs are connected in series, find the effective spring constant. Whenever springs are connected in series, effective should be 1 by K1, which is K here, 1 by K2, 2K, 1 by K3, 4K, 1 by 8K plus so on. 1 by K is constant, take it outside, 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus so on. 1 by K into, this is nothing but a GP series, its solution is A divided by 1 minus R. So, 1 by K into a first term 1, R is nothing but common ratio which is equal to 1 by 2, which gives rise to 2 by K equal to 1 by K effective, or K effective equal to K by 2. So, the answer is C. A particle of mass m is attached to a spring of spring constant K and has a natural angular frequency omega naught. An external force F of t proportional to cos omega t, where omega not equal to omega naught is applied to the oscillator. The time displacement of the oscillator will be proportional to. A spring is given, one end is connected to the rigid support, spring of spring constant K is given, to which a block of mass m is attached, which is on the floor. Now, this is executing simple harmonic motion with the angular frequency omega naught. Now, you have to apply external force F external. Now, it starts vibrating with angular frequency omega. Whenever force is applied, there is a restoring force. We can even write as force at the mean position in the opposite direction. Therefore, total force acting on the system is restoring minus external force. According to Newton's law, force is mass into acceleration, m into acceleration is omega naught square into displacement x. When external force is applied, frequency becomes omega square into x, which is x into m omega naught square minus m omega square, implies displacement x is f net divided by m into omega naught square minus omega square. Therefore, time displacement x is inversely proportional to m into omega naught square minus omega square. So, the answer is B. The period of oscillation of a simple pendulum of length L suspended from the roof of a vehicle which moves without friction down an inclined plane of inclination alpha is given by. Time period of pendulum is required. Now, it is on the inclined plane. 2 pi root of L by G, can replace it by G effective is the formula. Whenever pendulum is on the inclined plane, G effective equal to G into cos alpha, where alpha is nothing but angle of inclination. Therefore, time period is 2 pi into root of L by G cos alpha. So, the answer is E. A simple harmonic motion is represented by x equal to 5 root 2 sin 2 pi t plus cos 2 pi t. The amplitude of simple harmonic motion is. This is the equation of SHM due to the superposition of two waves. Therefore, to find the resultant amplitude, both parts are in the same form. Therefore, convert that 5 root 2 sin 2 pi t plus 5 root 2 cos 2 pi t can be written as sin 2 pi t plus pi by 2. Now, between these two waves, phase difference equal to pi by 2 or 90 degree. Whenever phase difference is 90 degree, resultant amplitude is square root of A1 square plus A2 square. Since A1 and A2 are equal, you can write as root 2 times A1, which is root 2 into A1 is 5 root 2, which is 5 into 2 equal to 10. So, the answer should be 10 centimeter. The instantaneous displacement of a simple pendulum oscillator is given by x equal to a cos omega t plus pi by 4. Its speed will be maximum at time. Instantaneous displacement of simple pendulum oscillator is given. To find where its speed is maximum, so find the value of V. V is nothing but dx by dt. If you differentiate, A into minus sin omega t plus pi by 4 into omega. For V to be maximum, sin function should be maximum, that is sin omega t plus pi by 4 is maximum. Maximum value is 1, implies omega t plus pi by 4 is sin inverse of 1, which is pi by 2, or omega t is pi by 2 minus pi by 4, which is equal to pi by 4. But omega is 2 pi by t, which implies t equal to pi by 4 omega. So, the answer is an organ pipe P1 closed at one end, vibrating in its first overtone, and another pipe P2 open at both ends, vibrating in its third overtone, are in resonance with a given tuning fork. The ratio of lengths of P1 and P2 is. In this question, two pipes are given, one is closed, another is the open pipe. The resonance in the tuning fork means both are vibrating with same frequency, but closed pipe is vibrating in the first overtone. So, frequency should be 3V by 4 times length L1. Open pipe is vibrating in the third overtone, implies 4V divided by 2 times its length, which gives rise to V cancels. You have to calculate L1 divided by L2. 2 ones are 2 twos are. So, L1 by L2 is nothing but 3 divided by 4 into 2, which is 3 divided by 8. So, the answer is C. The relation between time and displacement for two particles is given by y1 equal to 0.06 sin 2 pi into 0.04 t plus phi 1 and y2 equal to 0.03 sin 2 pi into 1.040 plus phi 2. The ratio of the intensity of the waves produced by the vibrations of the two particles will be. So, equation of two waves given, you have to calculate ratio of the intensity. Both are in the form A sin omega t plus phi form. Therefore, you can compare the amplitudes directly. Amplitude of first one is A1, amplitude of second is nothing but A2, but intensity is proportional to square of the amplitude. Therefore, I1 by I2 equal to A1 by A2 whole square. A1 is 0.06, A2 is 0.03, it's a square, which is 6 by 3 to 2 square equal to 4. So, the answer is 4:1. So, C is the answer. A hospital uses an ultrasonic scanner to locate tumors in a tissue. The operating frequency of the scanner is 4.2 megahertz. The speed of sound in a tissue is 1.7 kilometer per second. The wavelength of sound in the tissue is close to. So, here ultrasonic scanner is used, sound wave has to propagate, its operating frequency and speed is given, find the wavelength. So, V equal to F into lambda, therefore, lambda is nothing but V by F. Speed is given as 1.7 kilometer, frequency is 4.2 megahertz, which is equal to 4 into 10 to the power minus 4 meter. So, the answer is E. A man sets his watch by the sound of a siren placed at a distance 1 kilometer away. If the velocity of sound is 330 meter per second, how the man has to set his watch? So, siren is produced at a point. After traveling certain distance, 1 kilometer should reach the person. Definitely time taken is larger, means his watch should be set slower. Find out the time taken. That time is nothing but time taken by the sound to reach the person, which is equal to distance travelled divided by velocity. Travels a distance of 1 kilometer with a speed of 330 meter per second, which is approximately 3 seconds. So, sound reaches the person after 3 seconds, hence his watch is set 3 seconds slower. So, the answer is B. A tuning fork of frequency 512 Hz makes 4 beats per second with the vibrating string of a piano. The beat frequency decreases to 2 beats per second when the tension in the piano string is slightly increased. The frequency of the piano string before increasing the tension was. In this question, tuning fork of frequency 512 Hz makes 4 beats per second with the vibrating string of a piano is given. Therefore, frequency of piano should be more by 4 Hz or less by 4 Hz. Therefore, 516 Hz or 508 Hz. As the tension is increased, frequency also increases. Frequency is proportional to root of tension. As tension increases, frequency of piano increases. As the frequency of piano increases, if difference between the tuning fork and piano frequency is decreasing, means its original frequency is smaller than the tuning fork. Increasing means its original frequency is larger than the tuning fork. Here it is decreasing, therefore original should be smaller than the tuning fork, implies frequency of piano is 508 Hz. So, the answer is D. The equation of a simple harmonic wave is given by y equal to 3 sin pi by 2 50t minus x, where x and y are in meters and t is in seconds. The ratio of maximum particle velocity to the wave velocity is given by. So, ratio of maximum particle velocity, which is nothing but omega e, divided by wave velocity, which is given as omega divided by k is required, which is equal to omega cancels, which is nothing but a into k. Now, to find out k, modify the formula. 3 sin 50 pi t by 2 minus pi by 2 into x is of the form a sin omega t minus kx. A is 3, k is pi by 2. So, value is 3 pi by 2. So, the answer is B. If you study the vibration of a pipe open at both ends, then the following statement is not true. In case of open pipe, open end has more freedom to vibrate. Definitely it is the region of antinode. So, first one is the correct statement. Open pipe consists of all harmonics, both even and odd. Therefore, second and third are also correct. But pressure change is maximum at the node, minimum at the antinode. In case of open pipe, open end consists of antinode where pressure is minimum. Therefore, fourth answer implies D is not true. A string is stretched between fixed points separated by 75 centimeter. It is observed to have resonant frequencies of 420 Hz and 315 Hz. There are no other resonant frequencies between these two. The lowest resonant frequency for this string is. So, between 420 and 315 Hz, there is no other resonant frequency, means they are the successive frequencies. In case of a stretched string, frequency difference is nothing but 1:2. So, frequencies differ by 1. If I take one frequency is n into f, another should be n plus 1 into f. N into f is 400, n into f is 315 Hz, n plus 1 into f is 420. If I subtract 1 from the 2, we get f equal to 420 minus 315, which is 105 Hz. So, the answer is D. Two cars moving in opposite directions approach each other with the speed of 22 meter per second and 16 meter per second respectively. The driver of the first car blows a horn having a frequency 400 Hz. The frequency heard by the driver of the second car is, velocity of sound is 340 meter per second. In this question, two cars are approaching each other. Car A is moving with a speed of 22 meter per second and car B is moving with a speed of 16.5 meter per second. The driver of the first car blows a horn having a frequency of 400 Hz. So, first car is nothing but source now. Sound from the source should move towards the observer in the second car. Find the frequency of the sound heard by the second car. That is f dash equal to f into v minus v naught by v minus vs. F is true frequency, which is equal to 400 Hz. V, velocity of the sound 340 minus Observer is moving opposite to the sound, so take V naught negative minus 16.5 by 340 minus. Source is moving in the direction of sound wave, take it as positive plus 22, which gives rise to 448 hertz. So the answer is D. The force constants of two springs are K1 and K2. Both are stretched till their elastic energies are equal. If the stretching forces are F1 and F2, then find the ratio of F1 and F2. So, two strings are given, they have same elastic potential energy. So, U1 equal to U2 can be written as half K1 x1 square equal to half K2 x2 square, half cancels out. To find the ratio of force, convert this one into force form, that is K1 x1 into x1 equal to K2 x2 into x2. K1 x1 is F1, K2 x2 is F2 into x2. Therefore, F1 by F2 equal to x2 by x1, but x is inversely proportional to square root of k, therefore should be root of k1 divided by k2. So the answer is C. Two simple harmonic motions of angular frequency 100 radian per second and 1000 radian per second have the same amplitude. What is the ratio of their maximum acceleration? Ratio of maximum acceleration is given, which is nothing but omega 1 square by omega 2 square, because acceleration is omega square into A is the same here, which gives rise to 100 by 1000 square, which is 1 divided by 10 square. So the answer is D. A particle executes a simple harmonic motion with amplitude 0.2 meter and time period 24 seconds. The time required for it to move from the mean position to a point 0.1 meter from the mean position is. In this question, amplitude of vibration and time period are given. You have to calculate time required for the particle to move from mean position to a point at a distance of 0.1 meter. So displacement of the particle is given by A sin omega t. Omega can be written as 2 pi by t into t. Distance of the point is 0.1 meter, amplitude is 0.2, time period is nothing but 24 seconds. You have to calculate time t. 0.1 by 0.2 is 1 by 2, which is sine of pi by 12t. Pi by 12t is sine inverse of half, which is nothing but 30 degree. Pi divided by 6 implies t equal to 2 seconds. So the answer is E. A pendulum is executing simple harmonic motion and its maximum kinetic energy is K1. If the length of the pendulum is doubled and it performs simple harmonic motion with the same amplitude as in the first case, its maximum kinetic energy is K2, then relate K1 and K2. Maximum kinetic energy is given by the formula half m omega square into A. Here mass is constant, they have same amplitude, A is constant, therefore K proportional to omega square. Length is changed here, so omega depends on L. Omega is inversely proportional to root L, so omega square is inversely proportional to L. Therefore, K proportional to 1 by L implies K1 by K2 is L1 by L2. L1 is L, L2 is doubled means 2 times L implies K2 equal to K1 by K2 equal to L2 by L1, which is 2L by L, implies K2 equal to K1 by 2. So, the answer is B. A tuning fork and sonometer give 5 beats per second when the length of the wire is 1 meter and 1.05 meter respectively. The frequency of tuning fork is. So, sonometer gives 5 beats per second with the tuning fork for 2 different lengths, implies in one case its frequency should be larger than the tuning fork by 5, another case smaller than the tuning fork by 5. Therefore, I can write as n plus 5 by n minus 5. Frequency is inversely proportional to length, so which is L2 divided by L. When length is smaller, frequency should be larger. So, n plus 5 by n minus 5, larger frequency, smaller length 1, smaller frequency, larger length, which is n plus 5 equal to 1.05 n minus 5.25, which gives rise to 10.25 equal to 0.05 n, implies n is 10.25 divided by 0.05, which is 205 hertz. So, the answer is, the velocity of sound in hydrogen is 1224 meter per second. Its velocity in a mixture of hydrogen and oxygen containing 4 parts by volume of hydrogen and 1 part by oxygen is. Here velocity of sound in hydrogen is given, you have to calculate velocity of sound in the mixture of hydrogen and oxygen. As the gas changes, density also changes. How velocity is related to density? Inversely proportional to root of density. Density of hydrogen is known, which is nothing but 1. Density of mixture is given by rho hydrogen V hydrogen plus rho oxygen V oxygen by V hydrogen plus V oxygen. Rho hydrogen is 1, volume of hydrogen is 4 parts. Rho oxygen is 16, volume is nothing but 1 part. V hydrogen 4, V oxygen is nothing but 1, which is 20 divided by 5, which is equal to 4. So, density of mixture is 4, density of hydrogen is 1. Therefore, velocity of mixture by velocity of hydrogen is root of density of hydrogen by density of mixture, which is root of 1 by 4, which is equal to 1 by 2, implies V mixture is V hydrogen by 2. V hydrogen is 1224 divided by 2, which is 612. So, the answer is B. The extension in a string obeying Hooke's law is X. The speed of sound in the stretched string is V. If the extension in the string is increased to 1.5x, the speed of sound will be. Extension in the string is given, you have to calculate speed. Extension in the spring depends on tension, tension depends on the speed. So, speed is proportional to root of tension, but tension in the string is proportional to extension x. Therefore, velocity v2 by v1 equal to root of x2 divided by x1. Extension in the first case is x1 x, second case is x2, which is nothing but 1.5x, which implies v2 equal to root of 1.5 into v1, which is equal to 1.22 into v. So the answer is A. The ratio of intensities between two coherent sound sources is 4:1. That is I1 divided by I2 is given 4/1. The difference of loudness in decibels between maximum and minimum intensities when they interfere in space is. You have to calculate the difference of loudness in decibels between maximum and minimum intensities when they interfere in space is. You have to calculate difference in the intensity level L1 minus L2 whenever they have maximum and minimum intensity. So 10 log I maximum by I minimum is difference in the loudness level. I maximum divided by I minimum is 1 plus root I2 by I1 whole square by 1 minus root I2 by I1 whole square, which is 1 plus root of 1 by 4 square by 1 minus root of 1 by 4 square, which gives rise to 1 plus 1 by 2, which is 3 by 2 square, 1 minus 1 by 2, which is 1 by 2 square, which is equal to 9. Therefore, L1 minus L2 is 10 log I maximum by I minimum equal to 9, which can be written as 10 into log 3 square, which is 20 log 3. So the answer is B, 20 log 3. The equation of a standing wave is y equal to 0.8 cos pi x divided by 20 sin 200 pi t, where x is in centimeter and t is in second. The separation between consecutive nodes will be. Equation of a standing wave is given. You have to calculate separation between the consecutive nodes. Separation between the consecutive nodes is always length of a loop, which is equal to lambda by 2. To find this, we require lambda. Get the value of lambda from the equation. So this is of the form A cos kx sin omega t, equation of stationary wave. So from that, k equal to pi divided by 20, but k equal to 2 pi divided by lambda, pi cancels, therefore lambda equal to 40, x is in centimeter, 40 centimeter, therefore separation equal to lambda by 2, 40 by 2, which is 20 centimeter. So the answer is B. If the equation of a progressive wave is given by y equal to 4 sin pi t by 5 minus x by 9 plus pi divided by 6, then which of the following is correct? Either calculate velocity, wavelength, amplitude and frequency. To find that, convert this one into standard form of progressive wave. We can write as 4 sin 2 pi t by 10 minus x by 18 plus pi divided by 12 is of the form a sin t by t minus x by lambda plus 5, implies amplitude is 4, time period is 10, wavelength equal to 18. So wavelength equal to 18 meter is there in the answer. So the answer should be. A simple pendulum performs simple harmonic motion about x equal to 0 with an amplitude a and time period t. the speed of the pendulum at x equal to a divided by 2 will be. So, simple pendulum performs simple harmonic motion about the mean position, amplitude of vibration is given a, time period is given t. You have to calculate speed of the pendulum at a distance of a by 2, write it in terms of time period. That speed is given by omega into root of a square minus y square, y is given, convert omega into time period form 2 pi by t into root of a square minus distance is a by 2, a by 2 whole square, which gives rise to 2 pi by t into root of a square minus a square divided by 4 is 3a square by 4, which is root 3, root 4 becomes 2, 2 cancels, pi into a divided by t. So, the answer is root 3 pi a by t. So, D is the answer. 3 sound waves of equal amplitudes have frequencies n minus 1, n and n plus 1. They superimpose to give beats. The number of beats produced per second will be. In this question, 3 frequencies are given, they superpose to give beats. One is n minus 1, second is n, third is n plus 1. Between n minus 1 and n, difference is 1 sound is heard, n and n plus 1, difference is 1 sound is heard. Between first and the third, difference equal to 2 sound is heard. Therefore, divide it into equal. So, first between the 2, 1 sound is heard in the 1 second, second 1 sound is heard in the 1 second, third 2 sounds are heard in 1 second, divided to 2 equal in 1 half 1 sound, next implies end of first second. 2 by 2 is 1. These 3 are heard simultaneously, which is equal to single sound. Along with that, this is heard, implies total. We can hear 2 sounds. So, the answer should be D.